In 2017, a remarkable celestial visitor entered our solar system, unlike anything we had ever encountered before. This object, named Oumuamua, meaning scout or messenger from afar in Hawaiian, became the first known interstellar object detected passing through our planetary neighborhood. Its appearance sparked global intrigue and a flurry of scientific investigations. An enigmatic visitor. Oumuamua's journey into our solar system began with its detection by the Pan-STARRS 1 telescope in Hawaii. This discovery was extraordinary, as its trajectory revealed that it was not gravitationally bound to our Sun, marking it as an interstellar wanderer. Unlike the familiar orbits of comets or asteroids, its hyperbolic path indicated it was simply passing through before exiting the solar system permanently. However, it wasn't just its origin that captivated scientists. It was also its peculiar properties. Oumuamua exhibited a unique cigar-like shape, estimated to be about 650 feet long, and displayed an unusual rotation pattern, resembling a tumbling motion. Unlike typical comets or asteroids, it lacked a visible coma or tail, raising questions about its composition and behavior. A scientific mystery. One of the most puzzling aspects of Oumuamua was its unexpected acceleration as it moved away from the Sun normally. Objects within a solar system adhere to the laws of celestial mechanics, where gravity dictates their motion. Yet, Oumuamua's speed increased in a manner that couldn't be fully explained by gravitational forces alone. Scientists initially hypothesized that the acceleration could be due to outgassing, a process where volatile gases are released as a comet heats up near the Sun. However, no visible gas emissions or dust coma were detected, challenging this explanation. This anomaly led researchers to propose alternative theories, ranging from mundane natural processes to more speculative ideas, such as the possibility of it being an alien probe or a solar sail, a lightweight structure propelled by radiation pressure. Theories and speculations. The mystery of Oumuamua's nature has inspired a wide range of theories. A fragment of a larger object. Some scientists suggest that Oumuamua might be a shard of a larger body, broken off during a collision in its home star system. Its elongated shape and tumbling motion could result from such a catastrophic event. A new class of object. Others propose that Oumuamua represents a previously unobserved type of interstellar object, distinct from comets and asteroids. This could include objects composed of exotic materials or formed under unique conditions in distant regions of the galaxy. Solar sail hypothesis. One of the more speculative ideas is that Oumuamua might be a solar sail, a thin, artificial construct designed to harness the pressure of starlight for propulsion. If true, this would imply an intelligent origin, sparking debates about extraterrestrial life and advanced technology. Natural hydrogen outgassing. Recent studies, including work by Jennifer Bergner from the University of California, Berkeley, and Daryl Seligman from Cornell University, suggest a more conventional explanation. They propose that Oumuamua might have been a water-rich comet exposed to high-energy cosmic rays during its interstellar journey. These rays could have converted some of the comet's water ice into hydrogen gas, which, when released near the Sun, could account for the observed acceleration without visible emissions. Oumuamua's legacy. Despite its brief visit, Oumuamua has left a lasting impact on astronomy and our understanding of interstellar objects. Its discovery highlights the dynamic nature of the cosmos and underscores the fact that our solar system is not isolated but part of a vast, interconnected galaxy. It also serves as a reminder of how much we have yet to learn about the universe. As Oumuamua recedes into the depths of space, becoming a faint speck beyond the reach of current telescopes, its legacy continues to drive scientific inquiry. Future advancements in technology and observational capabilities may one day allow us to study similar interstellar travelers in greater detail, unlocking the secrets of these cosmic messengers and shedding light on the mysteries of the galaxy. With the model proposed by Seligman and Bergner, which explains its unusual characteristics. They suggest that Oumuamua is indeed a comet, but an exceptional one. The absence of a visible coma or tail can be attributed to the fact that atomic hydrogen is much lighter than the materials typically ejected by comets, thus it doesn't carry much dust. While Bergner and Seligman's hypothesis is compelling, it's important to note that not all in the academic community are convinced. Karen Meach, an astronomer at the University of Hawaii, still believes that the traditional interpretation of Oumuamua as a comet might be correct. She posits that the object could have had a small amount of dust, which would also explain the lack of a visible coma or tail. One of the more popular theories that captured the public's imagination is that Oumuamua could be an extraterrestrial probe. Its elongated shape and strange trajectory sparked speculation that it might be a piece of advanced technology. This hypothesis gained attention when Avi Loeb, an astrophysicist at Harvard, suggested that Oumuamua could be a thin, flat, almost rectangular object, perhaps a probe sent by an advanced extraterrestrial civilization. However, this theory has not held up under scientific scrutiny. If Oumuamua were a probe, it likely would have emitted some form of radiation or signal, neither of which have been detected. Additionally, its tumbling motion doesn't align with what we would expect from a probe designed for steady movement or data collection. The trajectory and characteristics of Oumuamua can be better explained by natural phenomena, as discussed in previous sections. The theory proposed by Jennifer Bergner and Daryl Seligman, which suggests Oumuamua is a hydrogen-rich comet, accounts for its strange attributes without requiring extraterrestrial intervention. While the idea of Oumuamua as an alien probe taps into our fascination with the unknown and the possibility of intelligent life beyond Earth, it also serves as a cautionary tale about the dangers of speculative hypotheses. While these theories are intriguing, they can sometimes divert attention from more plausible explanations. Although Oumuamua's unusual traits have baffled astronomers, the most likely explanation is that it is an extraordinary type of comet or asteroid. Its long journey through interstellar space likely altered its composition, creating a crust that trapped most of the frozen gases inside. This hypothesis is consistent with NASA's Hubble Space Telescope observations. The discovery of Oumuamua is significant because it suggests that trillions of such objects may be passing through our solar system, and we have only just begun to study them. The upcoming launch of the giant Magellan Telescope in Chile, expected to begin collecting light in December 2023 with full operations starting in October 2024, may allow us to identify more objects like Oumuamua. The data will be made publicly available, opening up new avenues for understanding these mysterious interstellar visitors. Beyond telescopes, advances in propulsion technology and data analysis could enable us to study these objects more closely. Imagine a future where we could send a probe to rendezvous with an interstellar object, collect samples, and transmit data back in real time. The European Comet Interceptor mission, which was recently approved, represents a major leap in our ability to study interstellar objects like Oumuamua. Unlike previous missions designed to observe objects within our solar system, the Comet Interceptor will focus on objects from outside our system. Led by ESA with support from JAXA, the mission aims to target a comet that has spent little time in the inner solar system and might be visiting for the first time. The spacecraft will consist of a main unit and 2 probes that will observe the comet from different angles, creating a 3D profile of its structure. The mission is expected to launch in 2029 and will travel with ESA's Exoplanet Scout. Once in space, the Comet Interceptor will wait for an interstellar object to pass through the solar system, positioned at the second Lagrange point, L2. 1.5 million kilometers behind Earth. When such an object is detected, the spacecraft will alter its course for a close flyby, capturing high-resolution images and gathering data on the object's composition, structure, and more. The discovery of Oumuamua has opened a new chapter in astronomy. How common are hydrogen-rich objects like this in the universe? Are there other interstellar objects with different shapes and behaviors? Most importantly, how can we better prepare to study these objects in the future? This represents a glimpse into future discoveries and encourages us to prepare for the next generation of interstellar visitors, which may be just as mysterious, if not more so.